All right, this video covers section 2.2. We're doing a little more with concepts related to functions and their graphs. Okay, so some of your homework is going to ask you to identify intervals where a function is increasing, decreasing, or constant. All right, so here's pictures that show you what is probably pretty obvious. When you're looking at graphs, read them from left to right like you would a book. And so if f is increasing on some interval, like the interval we're talking about is like x values, if it's increasing on the interval from a to b, then from left to right it should be rising. Okay. All right, so as you get, if x1 is less than x2, then what you know is that f of x1 will be less than f of x2. If it's rising, if some x value is less than some other x value, then you know the corresponding y values are related in the same way. But look at this graph here. Okay, from left to right, you see how it's falling? We say the function is decreasing on the interval from a to b. Okay, so here's our interval from a to b. It's an interval of x's. You're really giving the x's where the function then would be decreasing. And then if x1 is less than x2, meaning it's more to the left of x2, so they're talking about x1 being less than x2, just meaning x1 is to the left of x2. Notice that the corresponding y values here, see those are the corresponding y values. See how the y value for f of x1 is actually taller, bigger, greater than the y value for x2. Where on this one, the y value for x1 and the y value for x2, the y value for x1 was less. Okay. And we say that a function is constant on some interval from a to b if you look at the x values and the y values wind up being exactly the same. So from when x1 is to the left of x2, doesn't matter, the y values are going to be equal to each other. We say that's constant. All right, now this is kind of related to slope back with lines. So remember how if you had a line that was rising versus falling versus constant, then here you knew the slope was some positive number. Here you knew the slope would be some negative number. Here the slope would be 0. And there was one more case with lines, and that would be if you had a vertical line, and there the slope is undefined. Okay, so it's related to that. So rising, falling, constant is kind of like having a positive slope, negative slope, or a slope equal to 0. And then the undefined case doesn't happen because we're talking about functions typically. All right, so let's try to do this question. We're given a graph, and our job is to determine the intervals on which the function is increasing, decreasing, and constant. The intervals are talking about intervals of x, okay? They're what x values, for which x values is the function increasing, decreasing, and constant. Okay, so when you're looking at the first one, it looks like here, I'm going to do rising. It looks like here it's rising until I get to this spot. And then when I get to here, okay, between those two it seems to be falling. And then here it seems to be rising again. Okay, so if I wanted to know where is it increasing, where is the graph going up as I look at it from left to right, you want to report the intervals of x values. So that arrow means this keeps going. So you have x's from negative infinity until you hit what that appears to be, where that high point appears to be, which is, or looks like -1. And these are going to be reported as open intervals. They're going to have parentheses on the edges. And then it's also rising from 1, an x value of 1 to infinity. So these should be x's, okay? What you're reporting here should be x's, okay? And then technically these are sets, so you should have a union symbol, but some technologies you just put a comma between the two. So just kind of either a comma or a union is what you'll see in between those. All right, and then the function is decreasing on x values from -1 to 1, what appears to be -1 to 1, okay? All right, now look at the one in the middle. See how this right here is just nice horizontal line until I get to the origin, okay? And then it's rising. So it's rising here. It's constant there, okay? So for increasing, that would be from an x of 0 on to infinity, okay? All right, for decreasing, there isn't any, okay? And then for constant, we didn't have any on the first case. So here, no decreasing. Here, no constant. For constant, it would be from -infinity until I hit the origin, which is a 0. All right, on your intervals, make sure you're going from left to right when you report them, smallest to largest, okay? All right, let's look at this guy. I've got falling. I've got falling. Here it's constant. Here it's constant. Okay? And even though the slope of these lines is different, it's falling more rapidly on this one. I don't need to distinguish that. Since this is nice and continuous all the way through, I won't need to separate that. So I can say that it's constant. Let me just write the words again here. So we're going to have decreasing just from an x of -4 to an x of 2. Okay, make sure you're using x's. So I'm looking at that point, but I'm not looking at the y coordinate of that point. I'm looking at the x of -4 to an x of 2 right here. Okay. And then for constant, I have two pieces. I have from an -infinity until I hit -4, and then again when I get to 2 and go towards positive infinity. So identifying the intervals here is a lot like doing domain, right? Because you're reporting the x's for some portion of your graph. But it's just thinking about where is the graph rising, falling, or staying the same, constant, okay? All right, let me go ahead and do this concept also. Here, we're talking about maxes and mins, all right? So there are functions where, like a parabola, where you have an absolute lowest point. They would call that an absolute minimum. Okay, so that can happen. All right, but a lot of times you don't, you are interested in minimums and maximums that might not be overall mins or maxes, but like on some interval. If I cut a portion of the graph, it's the lowest point in that portion, right? So if I cut off a portion of the graph that they indicated there, this spot would be the lowest spot in that region, and then in that interval. And then here I could find, I could snip off a portion of the graph that would make that the highest point. So we could call that a relative maximum. Relative versus absolute. If you've had this before, you might have used the term local, okay, for relative. And for absolute, you might have used the word global. Local and global go together, okay? So a function value, f of a, is a relative, let's see what they want it to be. They want it to be a relative max, a relative maximum of the function at x equal a if I can find an interval, like if I can cut off an x values so that when I snip that portion of the graph, when I look at that portion of the graph from there to there, f of a is bigger than all the other y values in that interval. Okay. All right, and f of b is a relative minimum of a function if there's an interval containing b, so like might look at those x's, go to the function, and look just at this portion of the function here. If the value of the function at b is less than all of the other y values around it. Okay. All right, now there's a little bit with how you state these, so I'm going to do that here. All right, so this one's kind of hard to do because I didn't put all the grid marks on there. Can't really tell what I meant for that to be. All right. It's kind of hard to see what I meant for that to be, whether I meant for that to be like 2, 2.5, or 3. So let's assume that this point right here is -1, 2. And let's assume this point is +1, -2. Okay, so I just, if you had indicated it as being 2.5 or even 3, I would have given you credit because these tick marks are missing and it's kind of hard to judge. It looked like it was a little less than halfway, is why I said the y value was 2. Okay. All right, so sometimes you see them say this, that -1, 2 is a maximum point, like a relative maximum. You'll sometimes see them say that, but really 2 is a relative maximum, and it occurs at x equals -1. Really, it's the y value that is the max or the min. Okay, this becomes important when you're answering word problems, where they might want to know where is the profit a maximum. It's the y value that is the actual maximum, and then the x is just where it occurs. Okay, so we sometimes informally say 1, -2 is and we would call that one a relative minimum. I didn't spell that right. Let me try that again. Minimum. We would say, though, really, -2 is a relative minimum at x equals 1. Or sometimes we even say there is a minimum of -2 at x equals 1. We sometimes leave out the word relative also. Okay. All right, so let's look at another guy. All right, so over here, there's one low point. Okay, it looks like it might go below -5, but let's estimate that point right there. Let's say that point is at 2.5, -5. These 2 points appear to be right on the x-axis. This one is the point 3, 0. This point is the 1, 0, 0. Okay, so for this one, we have 2 relative minimums. Sometimes they say minima when there's 2, minimums. We have 2 relative maximums, I should have said. And they might have just said maxima instead. And the points where that occurs are the ordered pairs 0, 0, and 3, 0. But really, you have relative maxes of 0. Let me do them separate. You have a relative max, I'll say, of 0 at x equals 0 and x equals 3, I could say. And then there's a relative minimum, and that appears to be at around, oops, I said 2.5, it's really 1.5, at around 1.5, negative 5. So I could say we have a relative min of the y value, negative 5, at x equals what appears to be 1.5. Okay, so you can have more than one relative maximum at the same spot. Okay. All right, now this graph on the right, those 2 points that we identified, those are actually absolute maxes, highest points overall. Okay, there's no absolute minimum, even though that's a low point in a region. This says you can find y values that are even smaller than that. Okay, and then this graph on the left, both of these spots right here, they're just relative max and mins. There's no overall. This we would assume keeps going.